So, today I'm showing you a video of the same motherboard that we checked last time. However, in this case, it will not be with the same boring Pentium G3220, but rather with a Core i7. Let's see if I can. I'm trying to see if I can focus it here. Kind of hard. Well, but you will have to believe me that this is a Core i7 4970K. No, 4790K, sorry. And the reason for this is, well, there's a couple of surprises next. But on some additional things, for example, you can add, because this motherboard has an mini PCI Express port, you can put a wireless card like this one, which again it is from eBay, and it is the wireless card, the 7260 AC from Intel. So one of the first things we are going to do, because this is the easiest thing to do, is just to plug this wireless card in the mini PCI port, PCI Express port. Naturally, we use the screw that was included with the motherboard, and put it there, and there it is. The antenna costed me £2.80, and also from eBay. It's a gigabyte one. It's the OM version. It works wonders, no problem. Now, naturally, before putting the processor, I already cleaned them, but I haven't applied the thermal surface purifier, so I will do so. 2 drops is more than enough. Well, 3 for the heatsink and 2 for the CPU, and we use them proceed to clean. This motherboard has been quite fantastic so far. I have no complaints whilst I was using it with the Pentium processor. However, like I said before, there are more surprises to come. But for the moment, let's just put the processor and the heatsink in the graphics card, in the motherboard. I am a bit distracted, I am sorry, but yeah, things happen anyway. So we'll wait a bit whilst the CPU and the heatsink dry themselves a bit. If not, we grab another piece of thing to clean it. I forgot the name, can't believe it. Anyway, we were already clean. We just applied the thermal surface purifier, and there they are. And again, the same trick applies. So we open this latch lever. We open in order to put the CPU on the socket, and again we do this with care. We have to remember that we have to align both the triangle here and the notches that you can see here. The motherboard has them as well, the socket rather. So it is rather easy. You just put that here, let the CPU fall down, and there it is. No problem. You put the lever back and you apply quite a bit of pressure until you finally seal it. Now that is done, which is the most cringe-worthy part of putting a CPU. Like we did before, we applied a small PIA here in the middle, not much. Remember that less is more. Well, there it is. Done. Now we put the heatsink. We have to remember that last time, because last time I committed an error, that this must be these small things here must be in the position for setting the heatsink into the motherboard, and that is because they have two. They one that goes all the way up, then the one that goes all the way down. The one that goes all the way up and allows to going down, because there is a position that does not allow that, is the correct one. But anyway, you will discover that when you try to put a heatsink eventually. We only align these plastic pins in order to put the heatsink, and then you press down. There it is. That metallic sound is signal that it has been properly done. There it is. There it is. And there's a cable here. And there it is. All set, no problems. Blah blah blah. Now we of course connect the fan to the motherboard, because we have to, otherwise there is no cooling whatsoever. Perhaps it changed a bit the length. It's not letting me. Here, ta. And there it is. This. Finally, there it is, like a glove. You check it just for fun. There it is, no problem, no problem, everything working. We will connect back. In this case, it is not anymore a hard drive, it is a SSD. Which again, from eBay, quite cheap to get. And there is it. Connect it to the power of the motherboard. And everything is ready now, and if you see, now I have some switches here and some LEDs. Great to know that the motherboard is working. What we will proceed to do now is to turn on the motherboard. But first we clear the BIOS. For this, in this case of this motherboard, we just switch the BIOS position the jumper into the reset position. You can consult the manual to do that. But otherwise, it is annotated in the motherboard. And then we can actually put this in a position that it allows me to connect all the other peripherals of it. And we can leave this here, that's no problem. We get mouse and keyboard from my other computer that is running just besides me, and let me check that it is. I am getting a bit low in light here, which is not great. This is the UK, so I pretty much can't do anything about that. In fact, I am glad that I just had light. We plug mouse, boom, and we plug keyboard. And then, the most important part, we plug power. And now that everything is running, we just turn it on. Much more easier than than shorting the cables in there. I forgot one thing though, and that thing is none other than the HDMI. So I see that I have video. And I'm going to turn off and turn it on again. I got keyboard, I got video. The files of the UEFI has been loaded, and I'm gonna press F2 because what I will do now is to disable the post function. Sadly, this processor is 90 something watt TDP, but I want to avoid for the moment any sort of overload in the power. For that, well, I will check on the BIOS first. So, for next trick, like I said before, there's a couple of surprises. First, we'll use a skeleton made, Meccano skeleton made for this motherboard. You will see why soon enough, and it makes a lot of sense, considering that it allows us to mount a lot of things quite easily on the motherboard. 37 case that recently was released, I forgot the name of it, but this is just a case. It has not even Windows, because according to them you can customize it any way you want. Yeah, well, that customization is quite limited. I mean, if this is a set of Meccanos particularly designed for motherboards like this, I mean, what I'm trying to say is there is better ways to do customization on for motherboards, for cases in motherboards, and I found out that using Meccanos was rather easy to do and fast. I already had made this before, of course, but in this case I am reassembling it because I removed it just to put a new processor in, just in case. Nothing particularly tiresome, and just a couple of pieces, Meccano pieces, because I don't have all my Meccanos with me. I will come back to that part later, but hey. So, this is rather complicated from here. There is. And there is another west screw. I'm trying to put the 4 screws right away. Then we put tilt 1. Can adjust them later anyway. I'm not too worried about them at the moment, as long as they get fixed in their position. Oh, that is. And there it is. Now, what is the purpose of this? Well, one, a bit silly, but you can, because this antenna from Gigabyte has magnets, you can just put it in there and carry it away. Okay, not particularly exciting, I know, especially when doesn't want to cooperate. Might look like I am a bit clumsy, but I am doing this in a very fast way. I mean, in a hurry. So apologies if I look too clumsy. And there it is. More or less. Now, this hard drive, we can mount it right above here. I'm gonna put that in later in a fixed place. We can put it here, and we can fix it with some screws as well. This one, wrong screwdriver. I don't remember where I left the others. Oh, there it is. One screw. Two screws. We fix them properly. And voila! Now these very short SATA cables, I bought them also from eBay, was 2 for a quid. I think that's good enough. Boom. Great, we now have our SATA cable set and our hard drive. But that's good white. There is more. And that more is in the form of a piece of plastic. No, not really. That more is in the form of an R9 Nano, which we will proceed to connect to this motherboard. What a lovely thing, isn't it? How we can do that? Well, for starters, we use a riser cable like this, and we plug it to the motherboard. We ensure it is properly set, and then we plug it to the graphics card. Boom, boom, boom. Naturally, the graphics card actually requires external power. So what are we gonna do for that? Well, it comes in the form of a DA2 power supply from Dell. Quite nice, isn't it? This DA2 has a particularity that the plug resembles a lot the PCI Express power connector. However, it is not entirely the same. As two pins are not used for all purposes, one of them allows to see whether or not the power supply is on, and another is just a ground that we do not use. So we plug it to graphics card, and we then plug our power supply. Do you know that it is working because this LED is green? Now then we plug the motherboard. We got no power, and then we plug a monitor. For that we need our HDMI cable. Oh, right about here. Great, now we connect our keyboard again. And our mouse, because we need them. And then, well, we press the on switch. Graphics card is on, power is on, and we got video right away. Ladies and gentlemen, we have a R9 Nano running off this motherboard, which is very small. I am really impressed. And you can see it here. This is the HDMI cable which goes right to my monitor. My other computer is there. That's where I got the R9 Nano from. And this is my router. But anyway, we got it working. So that will be for today. I am just glad that everything has worked so far so well. See you next time. Bye bye. And now that there is much more light, you can see the final result here. Well, actually managed to kind of put everything in order. You can see the processor, the RAM here. Of course, you can see the graphics card, which is connected by 4X, only 4X PCIe Express version 2. That's not a bad thing, and I will show you why in a bit later. And for purposes, however, we have to do a bit of some extra things in the software side. The purpose of this was mainly to obtain something very small and still pack a punch of power, especially use it for research purposes. But it works very well for gaming. There is not that much loss, as I will show a bit later with some benchmarks. These are the two power supplies working, and the biggest one, of course, powers the GPU. Small one powers everything else. And I have been running it like this for around 3 days, not a single complaint. So indeed, I will show you, for example, the hardware part here. I will zoom it a bit. I'm running AMD Radeon R9 Fury series, blah blah blah. And well, I'm gonna switch the video to the computer now. But that is it. So here we are on the benchmark right now. I am running actually in the computer with the R9 Nano and the 4790K on the Team Mini ITX motherboard, and I am recording from it. Actually, I have Throttle Stop here, used to try and undervolt the processor in order to avoid not much consumption. However, I haven't noted much, at least within normal usage. However, if we really stress it on the Prime 95, for example, it really takes a toll in the system. So for example, I'm going to show you, if we run Prime 95 and I have an undervolt of minus 70 millivolts in both processor and cache. If we run it in blend mode, you will see that the processor will reach 62 watts compared to the 66, 67 watts when before the undervolt, but this is within normal parameters, because the motherboard only supports 65 watts power delivery to the CPU. Now I configured the TPL, the package power limits on the CPU to only go up to 65, and otherwise it should throttle, but I am not sure if it will throttle or not. But still, you can see that in blend mode there is not much of a problem, so we stop that. However, if we got into the torture test and into small FFTs, which is maximum heat, blah blah blah, because pretty much they fit all the data into the L2 cache of the processor. That means that the processor will work as fast as possible. So if you see, we have 87 watts power output, and that's not good, so we stop it just for avoid any kind of problems. And well, that's it. I just wanted to mention that detail. So anyway, we close this. Our temperatures are rather good. They do not go beyond 70 degrees 7 using that crappy Intel CPU cooler. But hey, anyway. So we go to the benchmarks now, and we compare it to many devices. So for example, we run the Firestrike test using 3D Mark, and because it's a nice benchmark, if you wish to say. In this case, we're using many Intel processors. In this case, for example, the one commonly found on Ultrabooks, well, back then when the 4th gen was all the rage, because right now we're on the 6th gen, you can see that we only got 632 points for this Ultrabook, which is a ThinkPad Yoga. Then we move on to my desktop computer, and I had previously an R9 290X card, and in it, there is no limitation whatsoever in here, because the motherboard uses an ASRock Formula Z97 chipset, and we got a respectable 10,368. Now we go back to only using the integrated graphics from the 4790K on the same computer, and we got 812, which, well, anyway. So we try again. Now the parameters here, I think it was that I changed the memory timings. I don't remember very well, but it's more or less the same. Doesn't count that much. However, we changed now. We put the R9 Nano, and we got a score of 12,181, which is a nice improvement over R9 290X. It's almost 2,000 in there. No complaints. Why more smaller package and footprint? Less power consumption as well. Now, the Firestrike Ultra, well, of course it will show a lower score, but that's the most extreme preset of the 3D Mark. And then the Skydiver, this was just for the giggles, to note that the GPU DOS indeed has coil whine. It's not that bothersome for me, it might be for some people, but not for me. And now we actually swap with our previous processor that we had on the thin Mini ITX build. It's the G3220. You can see that the score substantially decreases, and this is mostly because of the CPU, not so much for the card. But this is the difference that I want to show you from an i7 4790K to a Pentium G3220. It's almost it's around 5,000. 5,000 difference in a score, which is a substantial amount of score lower. I'm sorry for repeating it again. Anyway, we finally get into the part that we get the configuration with the thin Mini ITX motherboard. We see a score of 11,961. That's not too far from the 12,181. However, I began to note something, and this is very funny, because whereas Firestrike worked perfectly, when I started Heroes of the Storm, for example, my power brick powering the GPU, the Dell DA2, will simply shut down. So what I did is pretty much go into the Catalyst control center, and I had to do two things. So the first one was to limit the frame rate up to 60 FPS. I only have a monitor of 60 FPS, so I don't have any more need for more FPS at the moment. And then in AMD Overdrive, what I did was actually to lower the clocks. Now, you probably are going to say, yeah, but then it is not, it's really not worth it. I mean, if you are not using your full power of all your components, what's the point of buying those components in the first place? Honestly speaking, this was just for the fun of it, and also because it allows me to keep a very compact desktop computer that I can actually move around in, well, removing all the cables and putting most of the components in my backpack. Anyway, I decreased the clock settings down to 22.5%. That's around, it is around 785, no, on 75 megahertz. But that's really, really good enough considering the usage cases that I have, which is research and a bit of gaming. And in this case, the scores, first I lowered the power limit feature down to 50%. And also the clocks were down to 50% as well. That will be the card running a minus 50% of I forgot the name of this thing, of the performance of the forward limit feature, and up to minus 50% of the GPU clock. And that noted in a serious impact of my score here, which is 8,000. Again, a difference of 5,000, of 4,000 compared to my full rig with the Formula 1 Z97 motherboard stroke. And however, I increased that again down to minus 22.5% in the power in the clock frequency, and minus and I forgot again, I can't believe that, and minus and actually the power limit is down to 0. And so it's in the as it was from the factory. I only decreased the clock speed. As a result, I obtained a score of 10,212, which is okay, 2,000 less than my maximum score here, but I don't feel any difference. Again, I am not running this card with demanding games yet. But then again, if I compare the results compared to my R900 ITX, I am basically getting the same power out of it, and my brick, the Dell DA2 brick, does not shut down. Actually, the whole machine so far has been very stable, and I'm surprised that I quite built a Frankenstein in there using mechanos and whatnot. But I got a very, very compact setup, and it looks nice. And I can actually travel with it. I don't have to worry about other things. The monitor, in fact, comes from elsewhere. I don't count it in here. But anyway, I am happy with this setup, and I hope you also know that the Radeon card is connected by PCI 4X 2.0, which is compared to 3.0 16x is way less bandwidth, and still the card does an awesome job in providing very high frame rates. So that will be pretty much everything in this video, and I hope you like it. Thank you very much. Have a nice day. Bye bye.